Here we're asked to consider this funny looking function f of x is the absolute value of x divided by x. And it's pretty clear that I can plug in any value of x here except for 0. For instance, if I plug in 3, I get 3 divided by 3 is 1. If I plug in negative 7, I get absolute value of negative 7, which is plus 7, divided by negative 7 is minus 1. So to understand this problem a little better, we need to remind ourselves what absolute value does. Absolute value of x. Right. Absolute value is something that we have to kind of rethink in calculus. If you plug in a negative number, we tend to think of that as just losing the sign, but that doesn't quite work very well for our calc problems. We define absolute value as a piecewise function. If we plug in a value of x that's positive, then absolute value just returns the value of x. Same for 0. However, if I plug in a negative value, then what absolute value does is it gives me the opposite value back. So if I put in minus 3, I'm going to get the opposite of minus 3. If I put in a negative x, I'm going to get the opposite of that x. So now with this definition of absolute value, we see that f of x is going to be a piecewise function. Right? When x is greater than or equal to 0, we're going to have x divided by x. Well, we got to avoid 0, so we'll say when x is greater than 0. When x is less than 0, we're going to have minus x divided by x. This is, of course, just 1 and minus 1 when x is greater than 0 or when x is less than 0. The problem asks us to find the domain and the range. Well, the domain is all x but 0. So the domain is minus infinity. Let's write union there. And the range, what values can you get out? Well, I see 2, 1 and minus 1. So the range, when we want to write isolated values, a good way to do it is to use the curly bracket notation that says that's a set. It's a set containing minus 1 and a set containing 1, just those two elements.